to use p-value to make a test, the condition is that if p-value is greater than the level of significance, in other words, the level of alpha, if p-value is greater than alpha, I will accept the null hypothesis. Otherwise, I will reject. In other words, accept the null hypothesis right here, accept HO. If p-value is less than, alpha, reject the null hypothesis. All right. So, and by the way, how do we find p-value? We can find them in our calculator. So the first thing we want to do, anytime I'm given a proportion hypothesis testing, I will test the condition. What is the condition? Is NPQ is sample size multiplied by probability of success multiplied by probability of failure. Is it greater than or equal to 10? Another way of saying is the variance greater than 10. Okay, and I'll find out by using my calculator. So what is N in this question? N in this question is 125. P in this question given is actually what is P? 25 multiplied by P hat, the number of successes over number of X. So P hat is 103 over 125. Just so everybody knows. So use 103 over 125. That is the P. And I can get my calculator and find what P is. And what is P? And I'm talking about P, the P in binomial distribution. So 103 divided by 125, 103 divided by 125 is the P hat. And that is 0.824. So if P is 0.824, then Q, the probability of failure, 1 minus P is probability of failure, and that is 0.824. When I hit enter, I have 0.176. So I can now put them all in here, 0.824 multiplied by 0.824 multiplied by 0.176. Then when I get my answer, the answer is the value of the variance. Is the variance greater than 10? I'll get my calculator and find out. So N is 125 multiplied by the success, probability of success, 0.824, and multiplied by failure, and failure is 0.176. And when I get an answer, it has to be greater than 10. Or 18 is greater than 10, so I can do the confidence hypothesis testing. Therefore, the variance of the sample, the variance is greater than 10. So this is 18, and 18 is greater than or equal to 10. That's 18, greater than or equal to 10. Therefore, condition to convert from binomial to normal is satisfied. Another condition is that the sample size N must be less than 5% of the population. Well, what is the population of the whole America? The population is approximately 360 million. And I can just say that without actually trying to do this. 125 sample size of 125 over 360 million is less than 5% of the whole America. So the sample is insignificant. It satisfies the condition number 2. So I can do the test. So, and doing the test is easy because I have already satisfied the test. And when I do the test, my calculator will give me the p-value. My calculator will give me the p-value. So quickly, I will do the test. Let me make sure that I'm recording this because I have to record. Okay. All right. So what I'm going to do now is get my calculator. Because the conditions are satisfied, I'll go to start, STAT, arrow to test, and do a proportion test. I'm going to arrow down and do one proportion Z test. One proportion Z test. It's called one proportion Z test because the binomial satisfies the condition to convert to, so one proportion Z test, the binomial satisfy the condition to convert to normal. So it's one proportion Z test. It's Z test hypothesis testing. And it's asking me what is the population proportion given to me. The population proportion given to me is 0.7. What is the random variable given to me in this particular question? The random variable is 103. 103. And what is the sample size given to me is 125. And what kind of test am I doing? The kind of test I'm doing is a right tail test. I'm doing a right tail test. So I'll select right tail test. I like to draw whenever I'm doing a right tail test, any test, whether it's a right tail or left tail or two-tailed, I want to draw. So let me draw. So I just have drawn, and I found out that the p-value is 0.0012. So p-value is 0.0012. I want us to know that alpha given to us is 5%. So p-value found from my test is 0.0012, and alpha is 5%, which is 0.05. Therefore, p-value is less than alpha. Therefore, p-value is less than alpha. P-value is less than alpha. Whenever p-value is less than alpha, I reject the null hypothesis. So I will reject the null hypothesis. And what I can do, I'm just going to pull my whiteboard. I'm going to pull out my whiteboard so that I can show. I want to show how I rejected the null hypothesis. So I'm about to grab this and move it up. Okay, so I want to make sure I write the null hypothesis in this question is HO, population proportion, is equal to 0.7 because that is the population proportion I'm testing. This is the status quo. The alternative hypothesis is HA. You can write HA or HI colon. This is a proportion test, so you must write P. And it's a right tail test, so you write greater than. It's a right tail test, 0.7. And by the way, you have to draw a normal curve. Sometimes you don't have to, but I like to draw a normal curve. And because I'm doing a right tail test, I have to shade the right tail. And what kind of test am I doing? I am doing a test for Z, one proportion Z test, ZP hat. Okay. And now I'm given alpha. So this is state the claim number 2, alpha. My alpha is given to me as 0.05. And if I like, I can find the critical value, even though I don't, my calculator will give me critical value. I can find the critical value. Let me find it just to make sure we remember. I can find the critical value because the conditions are satisfied. I'll just do inverse norm, 0.05. So inverse norm 0.05 will give me the alpha. So the critical value is the area to the left given to me. Whenever you're given the alpha is the critical value. Okay. And the mean of a normal distribution is 0, standard deviation is 1. And I want you to know that I'm using normal because this question satisfies the condition to convert from binomial to normal. That's why. If the conditions are satisfied, you can use normal distribution to find your critical value. So that's what I'm doing right now. So the critical value is negative 1.64. But I want you to remember that the normal curve is symmetrical. Therefore, and it's a right tail test, I have to change this negative to positive. So it's going to be 1.644. I can actually leave it at 1.64. So this is the critical value. And actually now I found this boundary line. This is the boundary line. Okay, so the next thing is number 3. I am not doing it, but I put it in my calculator. I already did, and I'll get all the information from there. So I'm going to get all the information from there again. Go back to start, arrow to test, and do one proportion Z test, which is number 5. And I will get all this information that I already have. I've fed it in here, and I'm doing a right tail test. And I said I like to draw in all my hypothesis testing. Okay, so now that when the critical value, actually the Z is 3.025. In other words, the Z critical value is 3.025. I could be told to test the hypothesis with Z or P. But because I told to test with P, then I have to compare the P value with the alpha. So now I am comparing the P value with alpha. So P value is less than alpha. That means 18. The P value that I had there is 0.0025, something like that. That is less than alpha. 0.0012 actually. 0.0012 is less than alpha. And whenever the p-value is less than alpha, I will reject the null hypothesis. Whenever the p-value is less than alpha, I will reject the null hypothesis. So step 4, I have compared my p-value to alpha. It is less than alpha. So I'm going to go to make a decision. I will reject the null. Do not accept the null. I will reject the null hypothesis. You do not have any reason to go to alternative. You are either rejecting the null or accepting the null. You are either rejecting the null. The null is the status quo. So you either reject the null or you accept the null. So you go and say that you reject the null. And if it is a one-tail right test, if you rejected the null, the conclusion is that the alternative is correct. Therefore, the alternative is correct. P-value is greater than alpha. The population proportion is greater than alpha. So since I rejected the null, I can now say therefore, population proportion is greater than 0.7 or 70%. Because I rejected the null, I will take the alternative. Is that clear? Is that clear? So I rejected the null. I have taken the alternative hypothesis. All right. Any question? You can ask a question. You can ask a question. It's okay if you can ask a question. Is less than alpha. You could also be told to use calculate the test statistic. If you calculated the test, and by the way, if you are told to use the test statistics to do the test, the calculator also gives you the value of the test statistic. So you can say that the test statistics fell into the rejection region. It fell into the rejection region because it is 3.0303. It's 3.03. So I am going to draw that again, or I pull down the original, and then I will show where my test statistics falls. So the critical value fell here, but my test statistic, which is step 4, actually is 3.02. Therefore, my test statistic fell into the rejection region. So I reject the null. If the test statistic falls into the rejection region, you reject the null. If p-value is less than alpha, you reject the null. You do not have any business rejecting the alternative, because actually the null is the status quo. The null is what you are trying to, you are debating that. That is the hypothesis. So you are always trying to either reject the status quo, which is the null, or accept the status quo. Remember, if you reject the status quo when it's actually true, you committed type 1 error. If you accept the status quo when it's actually false, you committed type 2 error. Type 2 error is beta error. Type 1 error is alpha error. I know that we're talking about all kinds of things here, but by the time we do it again, you will get it. So this is an example with p-value, hypothesis testing with p-value. We could also be told to do a hypothesis testing with z-value. So let's get a question. Let's get another question. Let's get another question. And all right, so we need to make sure that I get the right question that I need. Okay, now I am looking for another hypothesis. 28 is a right tail test. Suppose I'm doing number 29. Notice that number 29 is a left tail test. So they're almost the same, except that this test, the status quo, is a left tail test. Okay, so if the status quo is a left tail test, I have to draw a normal curve and the left tail test and do exactly what I just did. So let's do that. Let's do that so that next class on Friday we shall do a T hypothesis testing. Okay, so I am going to state that claim here in this. So according to question number, the one we're just looking at, this question we are looking at right now, we are given that 45%. The null hypothesis is 45%. And they didn't give and write exactly what they gave me. So we're doing another t-test, and this is, p-test, p-test. The first thing is to check the conditions. Check conditions. Check conditions. And what are the conditions? So these are the given. The givens is that P, they stated the claim for us, HO, the population proportion is equal to, remember that the null hypothesis must be stated with equal sign. The null hypothesis must be stated with equal sign. So it is always going to be P equal to 0.45, and 0.45 is 45%, 0.45. And then you state the alternative. The alternative is also given to you, and this alternative is given to us as less than, so P is less than 0.45. And then we're given alpha. So alpha, this is 1, state the claim. 2, given alpha, and alpha is given to me as 5%. And because I'm given a left tail test, it is only a one tail test, left tail test. So, and I want to, first of all, check the condition. So is NPQ greater than or equal to 10? So let's check that out. All right, so the N given to me is 150. 150 multiplied by, what is my P? X. Everybody must know that the value of P hat, is always X over N. So what is X given to me here is 62 over 150. And if P is 62 over 150, then Q is 1 minus 62 over 150. And I can quickly calculate 62 over 150 so that I know that the complement is Q. So I'm going to get my calculator quickly and calculate the value of P. And so I'm going to ask my calculator, what is 62 over 150? 62 divided by 150. And I have, so that the P, the value of P hat this time is 0.413 approximately. So if the value is 0.413, I will now say I can store it in X. And then I say 1 minus whatever I stored in X. 1 minus. So I'm going to subtract that thing I stored in X from 1, and it is 0.59. Okay, so I will check it out, check out the condition. Look at my calculator again. So it is 0.41 times 0.59. 0.41 multiplied by 0.59. And when I multiply this, I am checking that this condition, is this greater than 10? Is the variance of this sample greater than 10? That's what I'm checking. I must check this condition before I do a proportion test. If I don't, then that's not, you are expected to check it anyway. Okay, so 150 multiplied by success, probability of success, 0.441, multiplied by probability of failure, 0.59, is not good to jump into doing hypothesis testing without checking it. Therefore, 36 is the value, and 36 is greater than 10. So it passed the test because 36 is greater than 10. I can now do the hypothesis test. And all I do is put the thing in my calculator and the answer will show up. So I'm just going to go to start, do one prop z-test, select one prop z-test, and let me go back because I think I've selected the wrong thing. I'm still going to go to start and go to test, and I'll arrow down to one prop z-test, which is number 5. And then what is the probability of success for population? For population, it is 0.45. So this is the status quo. In other words, what we are debating, the hypothesis we are debating, is that the population proportion is 0.45. And we shall use the sample that we're given to estimate this. So what is the random variable given to us in this question? The random variable given to us is 62. The sample size given to us in this question is 150. What kind of test are we doing? We're doing a left tail test. Left tail test. And I like to draw, so I'm going to draw. Actually, there is a lot of shaded area. Whenever there is a lot of shaded area, it signifies that the probability of accepting the null hypothesis is high. Your shaded area, whenever you draw a hypothesis testing and there's a lot of shaded area, it signifies that the probability is high. Well, let's see. But in other words, the p-value. See, the p-value is 18%, 18.34%. So already, because the p-value is, okay, so I'm going to say p-value is greater than alpha because it is 18 point something percent, 18% or more. 18% is greater than 5%. And because the p-value is greater than alpha, I will accept the null. Why am I accepting the null? Because p-value is greater than alpha. I am accepting the null because p-value is greater than alpha. So that's what I'm going to write now. Accept the null. Accept the status quo, HO. And this status quo says that P is equal to 0.7. Therefore, the status quo is still good. So I'm going to explain to those who sent me as a statistician to do the test. I will tell them the status quo is still good. There is no need of rejecting it. I did not reject it because the probability of accepting the null is high. So I accepted the status quo. You know, people hire you as a to go and do this test. And when you finish, it's good for you to talk to them terms. You're not going to be talking to them that the critical value or the null hypothesis or the test statistic. They don't know that. They don't know all this. That's why they paid you, they hired you. And so when you finish, you tell them that the status quo, which is what we already have, is still working. There is no need for changing it. So communicate with those who sent you, who hired you, that nothing is wrong with what we are doing right now. It's okay to continue with it. All right, so we're going to stop here. Next class, we shall do T hypothesis testing. So today we did P hypothesis testing, and next class we shall do T hypothesis testing. You must be wondering, why are we not doing Z hypothesis testing? See, we don't really know the population mean. So there's no way you can be looking for the population mean where you never know it and you never find it. The population mean is what we are testing. The population proportion, we are testing it, we don't know them. So we are actually going to use sample to estimate the population mean or